So up to this point, we have talked about how to graph polar coordinates on a polar coordinate system. We discussed the relationship between polar coordinates and rectangular coordinates, and now we're going to extend upon that idea to discuss the relationship between polar equations and rectangular equations. So just to start off, the first equation we have here, x squared plus y squared minus 2x, this is an equation in rectangular form. And the reason that we know that is because everything is written in terms of x and y. So this is going to be what equations in rectangular form look like. Now, the latter equation, r equals 2 cosine theta, this is an equation in polar form. And the standard way to write a polar equation is going to be r equals, something in terms of theta. So an equation in polar form. And so what we're concerned about is being able to go back and forth between equations of these particular forms. So let's start with an example. We are given x squared plus y squared minus 2x equals 0. This is an equation in rectangular form, and we want to change it to an equation in polar form. So what do we know? What relationships do we have to work with? Well, we know that r squared equals x squared plus y squared. We know that x is equal to r cosine of theta. We know that y is equal to r sine of theta. And we know that the tangent of theta is equal to y over x. Now, when we're working with these types of problems, we're really only concerning ourselves with these first three relationships. So let's see how we can use them. If we rewrite this, we've got x squared plus y squared minus 2x equals 0. And so look at what we have. We have x squared plus y squared, and we have an x right here. And we can provide substitutions from both of these relationships we stated. We can substitute an r squared for x squared plus y squared, and we can substitute an r cosine theta for x. So this is going to be rewritten as r squared minus 2 times r cosine theta equals 0. If I write this without parentheses, I'll get r squared minus 2r cosine theta equals 0. Now I want an equation in polar form, so I want something that looks like r equals, some type of expression. So how do I do that? Well, in this particular instance, I'm going to have to factor out an r. So I have r minus 2 cosine theta left, equaling 0. And here we're going to use that zero product property that we've used in the past. And so that says that if AB equals 0, then A equals 0 or B equals 0. So if the product of two things is equal to 0, we can set them both equal to 0. And so that's what we'll do here. So we're going to get that r equals 0 and r minus 2 cosine of theta equals 0. So this is already solved for, and here we get r equals 2 cosine theta. Now if we think about r equals 0, what's really happening? We've got a pole, we've got the origin or the pole, and then we've just got kind of a little point right here. That's the equation r equals 0. And so it's not too interesting, so we're not going to concern ourselves. We're only going to choose r equals 2 cosine theta as our answer. And so we've seen how to change this, x squared plus y squared minus 2x, a rectangular equation, into one in polar form. Let's try another example. We want to change y squared equals 5y minus x squared to polar form. So once again, the relationships we have to work with are r squared equals x squared plus y squared. We've got x equals r cosine theta, and we've got y equals r sine theta. Now, let's see how we can use this. So if we rewrite the equation that we're given, we've got y squared equals 5y minus x squared. And so what I want to do is I'm looking at this r squared equals x squared plus y squared, and I'm thinking to myself, how can I get x squared plus y squared present in this equation? Well, I can do that if I move everything to one side. So I'm going to add x squared to the left-hand side. So I'll get x squared plus y squared equals 5y. And then I'm going to subtract 5y. So I'm going to get x squared plus y squared minus 5y equals 0. From here, I'm going to make a substitution. So for x squared and x squared and y squared, I'm going to substitute r squared. And for this y here, I'm going to substitute an r sine of theta. Now, just like in the last problem, I'm going to factor out an r from each term. And so I'm going to get r times r minus 5 sine of theta. And then using the zero product property, I'm going to get r equals 0 and r minus 5 sine of theta equals 0. And then finally, that's just going to give me r equals 5 sine of theta. Now, once again, I'm not going to concern myself with r equals 0. That's a very boring equation. I'm only going to concern myself with r equals 5 sine of theta. So we've seen how to transform this rectangular equation to something in polar form. Now let's try to do it the other way around. We have r plus 3 sine of theta equals 0, and we want to write this in rectangular form. So one thing that we're going to need to do here is kind of to think of a trick. So we are starting off, let's just rewrite the equation. Some relationships. Once again, we have r squared equals x squared plus y squared. We've got x equals r cosine theta, and we've got y equals r sine of theta. So we're starting off with r plus 3 sine of theta equals 0. And so we don't really have any way to make a direct substitution. We have r, not r squared. We've got sine of theta, not r sine of theta. So what do? In this situation, we're going to employ a little trick. So the trick is to multiply both sides by r. Now you can multiply both sides of an equation by a variable without changing it. And so we're going to get r times r plus 3 sine of theta equals r times 0. So that's going to give us r squared plus 3r sine of theta equals 0. Now why did we do that? We did that because now we can substitute. We have an r squared, which we can substitute for x squared plus y squared. And we've got an r sine theta, which we can substitute for y. And so doing that gives the following. We get x squared plus y squared plus 3y equals 0. And so now we started off with the equation in polar form, and now we've got an equation in rectangular form. And we got that simply by using this trick of multiplying both sides by r and then substituting using the relationships that we know. Let's look at this last example. We've got r equals 2 cosine theta plus 3 sine of theta. We want to write this in rectangular form. So once again, I'll list out these relationships. We've got r squared equals x squared plus y squared. We've got x equals r cosine of theta. And we've got y equals r sine of theta. Now I'm going to rewrite my equation. R equals 2 cosine theta plus 3 sine of theta. And then let's see what we can do. We don't have an r squared. We don't have an r cosine theta or r sine theta. So once again, we're going to use this trick of multiplying by r to allow us to use some substitutions. So we've got r times r on this side of the equation and r times this whole right side of the equation. So I'll write out what just the multiplication looks like, and then I'll actually do it. So now this is going to simplify to r squared equals, and we're going to distribute to both terms, and we get 2r cosine of theta plus 3r sine of theta. Now, what can we do? It looks like now we can actually do some substitution. So we've got r squared, which we can substitute here. We've got an r cosine theta and an r sine theta. So if I rewrite this, I'm going to get x squared plus y squared equals 2, and then r cosine theta becomes x, plus 3, and then r sine theta becomes y. And so if I write this all on one side of the equation, minus 2x minus 3y equals 0, I have an equation in rectangular form that I've obtained by an equation in polar form. Okay?